Okay, so we will start with new unit 5, network standard and implementation. Okay, so let us look at some of the standard. Okay, for each technology, what are the standard and how it is implemented. Okay, so there are 3 network technology: Ethernet network technology, token ring network technology, fiber distributed data interface, or FDDI network. So in fact, some of the technology we have already come across a few times in our earlier units. So these are some of the technology, okay, and then we will look at for each technology what are the standard, okay, what are the things, what are the requirement. If we use the cable, what should be the speed, okay, how much should be the length of the cable, okay, and then which type of media or the cable should be used. Okay, so let us look at each network technology. So the first one is Ethernet network technology. Okay, so this Ethernet network is a segmented LAN technology that uses Ethernet NIC and twisted pair, coaxial cable, or fiber media. So any network, okay, that uses Ethernet NIC or twisted pair cable, coaxial cable, fiber media, okay, and also this Ethernet network technology, okay, it uses the bus topology, okay. I hope you all remember the topology. We have different topology, right? Bus topology, then mesh topology, star topology, ring topology, and so on, okay. So in case of Ethernet network, okay, mostly used our bus topology initially, okay, at the start of the network at the earlier days, okay. So bus topology are mostly implemented in Ethernet technology, Ethernet network technology, okay, where the cable used were twisted pair, okay, UTP or STP, okay, coaxial cable and fiber media, okay. So Ethernet is used to connect computers, printers, and servers within the same building or campus. Okay, so with the help of this technology, all the devices like printer, computer, server, and so on are connected, especially within a campus or in the same building. So here in this example, the first figure, this one, is okay, bus topology, where all the devices are connected to one single backbone. So this one is called as traditional Ethernet. Okay, so in earlier days, at the start of the networking, okay, when the networking was just introduced, okay, in the world, okay, Ethernet. Okay, Ethernet technology, usually the topology was bus topology, okay, and this is the scenario, okay, where all the devices are connected to this cable. So let's say, for example, the cable, okay, this backbone cable, the bandwidth is 10 Mbps, okay. Then this 10 Mbps, so this media, okay, let's say, for example, this cable, okay, it can carry or it can transfer the data, okay, bits per second, okay, 10 megabits. So 10 megabits per second, okay, the data are transmitted, each bit, okay, the bits are transmitted at in per second, 10 megabits were transmitted. Okay, so in order to use this cable, okay, all these devices in this network. So for example, here we have 2, 4, 6, 12, right? So 12 computer has to compete within each other. Okay, they have to compete within each other in order to use this cable. Okay, so do you all remember the method in terms of bus topology? Okay, how the transmission, okay, the cable is accessed. Do you all remember? In terms of bus topology, okay, or it is condition based, right? So here we use CSMA/CD and CSMA/CA, collision avoidance and collision detection method, in order to access the media, right? So here, okay, the Ethernet, usually Ethernet in Ethernet technology, okay, these two methods, CSMA/CA and CD, okay, are used, okay, are implemented, are to in order to access this media. So all this device, okay, they have to negotiate within each other in order to access this media, right? Even then, we can see that there are lots of collision. Maybe this computer is trying to communicate to this computer. At the same time, this computer might be trying to communicate to this computer. Then we can see there can be a collision, right? So this is a one collision domain. Okay, so here we don't have any device initially. Okay, so this is in fact it is also known as shared Ethernet, where this, okay, for example 10 Mbps bandwidth is shared within all of these 12 devices in the network. Okay, then with the by using the bridge, okay, we are dividing the segment, this segment into two, okay, one collision domain. With this one collision domain, okay, so with the use of bridge, we are now dividing this collision domain into two collision domain. Okay, so the bridge, so when we use this bridge, okay, in Ethernet technology, it is known as bridge Ethernet. Okay, so by using bridge, now these collision domain are divided into two collision domain. Okay, so initially 12 devices has to compete within each other in order to access this 10 Mbps bandwidth. Now by dividing this into two collision domain, okay, the 10 Mbps now is, okay, so 2 4 6, only 6 computer has to compete within each other. Okay, so 10 Mbps now is competed by or shared by the 6 computers. Similarly here, so collision domain is only here and only here, right? So bridge divides the collision domain, okay, and most of the time the bridge, okay, the port are usually 2 port or 4 ports, okay. But now by using this switch, okay, so switch is in fact also called as multi-port bridge. Okay, that means with multiple port, and it functions similar to bridge. Okay, so by using a switch, we can connect, so 12, all the 12, let's say the switch port is 12, so all the 12 computer can be connected to each port in the switch, thereby creating 12 numbers of collision domain. Now this computer has to, okay, it doesn't have to compete with another computer to use this bandwidth. So for each, okay, cable, the bandwidth would be 10 Mbps. So each, okay, by using switch, we can see that the collision domain is also divided, right? There, in fact, there is no collision at all. So each computer is connected to one port. So in order to access this media, this device can directly use it without any collision. Okay. So, and then also the bandwidth, the full bandwidth is used by this device. Okay. So thereby, there is a huge improvement in the network with the help of switch. Okay, so when we use switch in the Ethernet, it's called as switch Ethernet. Okay, so in the Ethernet LAN that uses switch to connect individual hosts or segment is called as Ethernet switch. Okay, so switch Ethernet can be defined as a LAN technology, okay, that connects host computer and network segments by using the switch. Okay, so the switch enables the device to utilize the full bandwidth. In this case, 12 computer or device has to share this bandwidth, which is 10 Mbps. In case of bridge Ethernet, 6 computer has to share the the bandwidth. But in case of switch, right, each device can use the full bandwidth. Okay, so switch enables the device to utilize the full bandwidth of the medium. So evolution from bridge Ethernet to switch Ethernet was a big step that opened the way to even faster Ethernet, right? By switching from bridge to switch Ethernet, the network, okay, performance was improved. Okay, the Ethernet was much faster compared to the traditional and the bridge Ethernet. Okay, so layer 2 switch is also known as N-port bridge. Okay, multi-port bridge or multi-port bridge with additional sophistication that allow faster handling of the packet. Okay, it also handles the packet much faster. Okay, so there are two main types of switch. Okay, you'll find there are two types of switch. Okay, the layer 2 switch and layer 3 switch. So layer 2 switch that operates at the data link layer of OSI model. So these layer 2 switch are also known as Ethernet switch. Okay, that does the forwarding of the packet. Okay, then you have another one called layer 3 switch. Okay, this one operates at network layer, which functions similar to the router. Okay, where the packet can be forwarded to another route network. Okay, so please do not get confused with the layer 2 switch and the layer 3 switch. Okay, okay, now next one is frame. Okay, so when the data are transferred in the Ethernet, okay, it's called as Ethernet frame. So let us see what are the informations included in this packet, okay, or also known as frame. Okay, Ethernet frame. So Ethernet frame controls data sent between two nodes. Each frame consists of several fields. Okay, so in Ethernet frame, okay, we have different fields. Okay, this first component are the header, okay, and the last one is the footer, and then this is the actual data. So in header, so in fact, when we learned about encapsulation and decapsulation, we saw that so many informations are being added or removed, right, at each layer, right, when it is transferred and received. Okay, so in the header part, let us see what are the information that are contained in Ethernet frame. Okay, the first one is called preamble. Okay, the 7 byte, okay, the total is 8 byte for the preamble. Okay, 7 byte is, okay, so this preamble, it again, it is either in bits, okay, zeros and ones, the pattern of bits, okay, zeros and ones. So the first 7 byte represents the start of the frame. So whenever, okay, the networking device sees, okay, this preamble, then they knows, okay, they knows that this is the start of frame. Okay, there are some data that will follow after this preamble. Okay, so 7 byte is the preamble, this that signifies the start of the frame. Okay, and then one last byte, okay, 1 byte that represents the start of the field. Okay, it's called as start of frame delimiter. Okay, SFD. Okay, then next field is destination address, which is of 6 byte. Okay, so this destination address is the address. It can be MAC address and also the IP address of the destination computer to which the frame is destined, or to which the frame is going to. Okay, or which device will be receiving this frame, the destination address. Then, so this destination address can be unicast, that means this frame is going to only one computer, or it can be multicast, going to a group of computers, or it can be broadcast. Okay, that means it is going to all the devices in the network. Okay, so it can be the address can be multicast, broadcast, or unicast. Okay, then you have source address, which is unicast, that means only one computer will be sending. Okay, so source address is the computer that, okay, device that is sending this frame. Okay, again, it is of 6 byte. Then you have a frame type of with 2 byte. Okay, so frame type defines the type of frame. Okay, is it the is it the, for example, email, or is it the web request, or is it the file transfer? Okay, so this defines the type of the frame. Okay, the 2 byte. Then this one, data. Okay, this frame is the this field. Okay, data field is the actual data. Okay, so this field carries the actual data, what information that, okay, that you are going to transfer. Okay, so the size for this data is minimum is 46 and maximum is 1500 bytes. Okay, and the last one, which is footer, is CRC of byte 4 byte. So we know why CRC is used, right? So this one, CRC, is used for to ensure that the data is being the data transmitted is correct. There is no disruption or manipulation or the change in data while transferring, right? So the sender calculate is on CRC, put it in the footer, and then send it to the receiver, destination computer. So on receiving, destination computer also calculate is on CRC based on the data, right? And then check the CRC that is calculated by the destination computer and the CRC that is embedded in the footer by the source computer is same or not. If it is same, then it is assumed that the data transfer is correct. There is no change in the data, or there is no the manipulation or modification of data on the way. Okay, if it is not same, then it's assumed that the data is not correct, not valid. Okay, something the signal or the data is being disrupted on the way. Okay, there is some modification. Okay, then the sender, the destination computer will ask the sender computer to resend the data based on the CRC. Okay, so this is the field, each field of Ethernet frame. Okay.
Madam,
Yes.
this CRC will acknowledge the data.
No, no, no. No, this is not acknowledged. CRC is used. Okay, if you all remember, during when we learned about the encapsulation and decapsulation, right? We saw that the standard computer will calculate the CRC, which is a checksum. Okay, there are methods, okay, techniques where CRC are calculated. So based on the data, okay, whatever the data that is being sent, CRC will be calculated by the sender computer. The sender computer will calculate and then store the CRC value. Okay, there will be, again, this CRC value is also in zeros and one. Okay, the patterns of zeros and one, and then it will store here, put it in the footer part, and then send it. Okay, then
Yes.
When this frame is received by the destination computer will, okay, take this data calculate its own CRC. Okay, then using the same technique, okay, it will calculate the its own CRC value, and then check the value that is being generated by the destination computer is same with the
Positive acknowledgement.
CRC value that is calculated by the source computer. So if the value, okay, the CRC value of the source computer and then CRC value of the destination computer, okay, that is calculated is same, assume that, okay, the data is valid. There is there is no change in data well during the transmission. Okay, nobody has changed the data, or maybe due to interference, okay, the data is not being affected. Okay, so it is assumed that the data is correct. Okay, and then it will acknowledge back. So acknowledge back will also be embedded in the data, the main data.
Positive acknowledgement. Yes, ma'am. Okay, thank
So
you, ma'am.
CRC is used for checking the data, whether the data is correct or not. Not
Yes, ma'am.
okay.
Okay, lah.
Okay. Then, okay, now let us look at the standard. Okay, so in Ethernet technology, okay, there are some standard that we have to follow, or the manufacturers, okay, if they are designing a cable or device or any networking interface or networking devices or cable or any connector, okay, if they are designing that, then they will have to follow some standard. Okay, as an administrator, network administrator, we also has to follow some standard. Okay, so there are some standard defined, okay, or designed by some organizations. Okay, so for Ethernet, okay, there is a standard defined by IEEE. Okay, so IEEE stands for, so IEEE is an organization, okay, which stands for Institute of Electrical and Electronics Engineers. Okay, so this um, organization, okay, they define the standard, okay, especially regarding the electrical and electronic devices, including your networking devices, okay, any cable and so on. Okay, so IEEE has a standard called as 802.x standard. Okay, so this in this standard, okay, the standard, there are some standard that are defined for Ethernet also. Okay, if you're using the Ethernet technology, okay, if it is Ethernet technology, network technology that is being implemented in your organization, then what are the standard that are followed? Okay, so this 802.x standard is a family of networking standard developed by IEEE in 1980s to address the rapid changes in networking technology. So 802.x standard are divided into several subcategories to address different networking requirements. So this 802.x standard defined by IEEE, okay, it has subcategories, okay, 802.2, 802.3, and 802.5. Okay, then each has its own standard defined specifically. Okay. So this 802.x standard, okay, these are for the networking standard. So let us look at it. Okay, first one, 802.3 standard. Okay, so 802.3 standard, it defines, okay, in this standard, it specifically, okay, defines about the media type, which media type to use. Okay, what should be the transmission speed for each media type, and which signal type or signal method to be used. Okay, so if it is twisted pair cable, either UTP or STP, right? Then the speed should be 10 Mbps or 100 Mbps, right? And then what should be the signal type? Is it baseband or should it be broadband? Okay, if it is coaxial cable or fiber optic cable, okay, what should be speed, transmission speed? 100 Mbps, 1000 Mbps, okay? So 802.3 standard, okay, IEEE issued the 802.3 specification to standardize the Ethernet and expand it to include a wide range of cable media. So it mainly focuses on the type of cable media. Okay. In addition to the media type, okay, which type of cable to be used, it also specifies the transmission speed and signal method. What should be the speed of that particular cable, and in which signal method to be used. Okay, so this type of network is most efficient in physical star or logical bus topology. Okay, so mostly it is implemented in physical star or logical bus topology. So this standard defines the physical and data link layer specification for Ethernet. So especially it is more focused on the lower two layers, that is physical and data link layer, right? How the signal, okay, they should be transmitted, which cable or media should be implemented, okay, and then how the media has to be accessed. So so this is 802.3, okay. Next one is 802.2 standard, okay. So we have 3, right? 802.2, 802.3 and 802.5. So in 802.2, okay, it mainly focuses, okay, on to develop the address, okay, the need for MAC sub-layer addressing in bridges. So 802.2 standard was, okay, mainly developed for MAC sub-layer addressing in bridges, okay, how the addressing should be done, okay, in terms of bridge when we use the bridges, okay. So 802.2 standard specifies the frame size and also the width. What should be the size of the frame for each frame, okay? How the frame should be divided into different fields, okay? And then for each field, what should be the size, okay? Then at which rate the frame should be transmitted, okay? So it's all of this information has been defined in this standard. So packet can be sent over Ethernet and token ring network using either copper or media, a fiber media. So if you're using, okay, the Ethernet technology or token ring technology, okay, and then the standard that is implemented is 802.2, right? Then you have to be using either copper or fiber media cable, okay. Okay, so these are 80 IEEE 802.x standard. Okay, now let us look at different standard that is called as 10 base standard. Okay, so 10 base standard describes the type of media used and the speed at which each type of media operates. Again, in terms of 10 base standard, it also defines the type of media, which media type to be used, and then what should be the speed, okay, the media or each cable should be operating. Okay, the cable standard specification contains 3 components. Okay, number indicating the media speed, then signal type, which can be either baseband or broadband, right? The other analog or digital, right? Then the code, last one is code, which is, okay, the code can be either for copper or fiber media, okay. So these 10 base, okay, standards again subcategorized into, okay, 10 Mbps, 100 Mbps, 1000 Mbps, and so on, okay. So this 10 base standard, okay, defines, it is divided into 3 components, first, second, and third. Okay, the first component is number, which defines the speed of the cable, that particular cable. Okay, and then the second component defines the signal type, which signal type is used in order to transfer the data. Okay, then the last one is the code, which defines the copper media, okay, either copper or fiber. So in this example, okay, we have 100, that means this particular cable, okay, is operating at 100 Mbps, okay, that means 100 megabit of data, okay, with 100 megabits is transferred in per second, okay. Then the signal type used is baseband, and TX code, this is the code, okay. Let us see what does it mean. So TX means it is UTP using 2 pairs of category 5. So these are the code. It can be either 2. So 100 base 2. If it is 2, then it means it is a thin net. Okay. And then the media is coaxial cable. Okay. If it is 5, thick net. T, right, UTP or STP. Then F means fiber optic. FL, fiber optic link. FB, fiber optic backbone. So this is usually for the backbone, okay, as used as a backbone. and this is for the normal link, right? Then FX, okay, multimode, okay, and so on. So these are the code, okay, where ER for extremely long range, okay, long range, and so on. So these are the specification, okay, these are the code for 10 base specification. Okay, so these 10 base standard, okay, are divided in further categories. Let us look at each category. The first one is called 10 Mbps Ethernet. Okay, so this 10 Mbps Ethernet, which means, okay, this the speed is for each second 10 megabit is transport. The transfer rate is 10 megabit per second. So this 10 Mbps, okay, standard, these are the standard and this is specification, okay. So 10 base 2, so 2, we know that the code for 2 is, it is thin net, right? So if it is thin net, okay, and then the signal type is baseband, the speed is 10 Mbps, okay, and then this is specified by IEEE 802.3, okay, and then again there is again more further category, 802.3a, okay, you see just 3, okay, 3i, 3j, okay, and then for the thin net, the total distance it can travel is 185 meters, okay. Similarly for thick net, 10 base 5, okay, 500 meters. Then if it is UTB cable, so if it is T, that means it is a UTB cable, 10 base T, 100 meter. If it is fiber, okay, 2000, okay, then these are all fiber, different types, okay. Fiber, this the normal link, this for backbone, this for long range, and so on. These are some of specification for 10 Mbps. Then you have fast Ethernet. So when you say fast Ethernet, okay, so fast Ethernet, the speed is 100 Mbps, okay. So you'll see if it is fast Ethernet, it is always 100 base T, okay, 100 base T4 or TX, FX, LX, and so on, okay. And these are the specification again: 100 base T, 100 Mbps, okay, speed is 100 Mbps, the signal type is base, and T indicates the UTP cable. So distance travel is 100, okay. Okay, then you have gigabit Ethernet, which is 1000 Mbps. The speed is 1000 Mbps, or it is also known as 1 gigabit, okay, or gigabit Ethernet. Okay, again here 1000 if it is gigabit Ethernet, okay. Then for the UTP cable, right, distance travel is 100 meters, okay. CS shielded, okay, balanced coaxial cable 25, okay. And if it is fiber with long range single mode, okay, 5000 meter, okay, the wavelength is 1300 nanometer. And if it is multi-mode, okay, then again 100 nanometer, 1300 nanometer, 550 meter. Okay, so these are some of the specification. Then you have 10 gigabit Ethernet again, which is 10,000 Mbps or 10 GB, okay, Gbps, or 10 gigabit, okay. So we write it as 10G, okay, 10G base X, okay, 10G base SR. Again, these are the specification. So these are again some of the specification for 10 gigabit. Okay, so these are the 10 gigabit Ethernet specification, okay, where it is defined by 10G, okay. Okay, so these are the now fiber wavelength. When fiber is used, okay, if it is okay 1000 Mbps, okay, 1000 Mbps, then for the long range, okay, single mode, then wavelength should be 1300 nanometer, okay. If it is short range multi-mode, then it should be 850, okay. So these are the specification again for the fiber optic, okay. For 10G base, okay, multi-mode is 850 nanometer. 10G base single mode, it is 1310 nanometer, okay. And extremely longer ranges, okay, which is used by single mode, is 1550 nanometer. So these are some of the specification, okay. So give a specification where this first number indicates the speed, then the type, it can be either base or broad. Base means it is baseband, broad means it's broadband, okay. And then the code defines the type of the media used, okay. So these are the some of the standards, okay, specification for the Ethernet network technology, okay. So in next class, at the token ring network technology and FTTI network, and what are the standard used in each network, okay.